SQL is an elegant abstraction of complex data manipulation concepts, and ORMs can sometimes be an overcomplicated abstraction of an abstraction. But when it comes to Drizzle, I think they got a lot right. The Drizzle Object Relational Mapper is a tool that you can plug into your TypeScript projects that allow you to translate models represented in your database into well-defined TypeScript objects in your code. Drizzle provides a SQL-like way of interfacing with your data. This means that if you know SQL, then you know Drizzle, and you don't have to mentally translate ORM semantics back to SQL when developing. Drizzle's development pattern consists of using Drizzle schemas, which represent the shape and schema of a given table directly in your codebase to execute query commands against your database. But Drizzle is more than just an ORM. By installing Drizzle Kit as a dev dependency, you'll be able to instantly stand up an environment that allows you to explore data and execute SQL commands manually. Drizzle Kit also provides commands that can be used to manage the entire lifecycle of your database tables. These commands are really powerful and can dramatically improve your developer experience. The core focus of this video will showcase patterns on how you can improve the process of managing your schemas with Drizzle. We will do so by illustrating two concepts found in Drizzle's migration docs. These concepts are database first versus codebase first schema management. We will first start by taking a look at a codebase first schema management example. Let's head over to an existing TypeScript project and get Drizzle set up. In this video, we are going to be connecting to a free Cloudflare D1 SQL database. I recently released a video on how to develop on and deploy to Cloudflare's compute platform. So if you're interested in learning more about D1 and Cloudflare, take a look at that video. If you don't use D1, you can still follow along as the process is the same for most Postgres, MySQL, and SQLite providers. I always get started by configuring my database credentials in the Drizzle config. Each database dialect will require different credentials, which you can find in the Drizzle docs. For Cloudflare, you can get your account ID in the Workers dashboard. Database ID can be found by opening your database. You can go through the process of creating a new API token in Cloudflare and assigning D1 under permissions. These credentials can be placed in a .env file, and then your node process can pick them up. Now head to your package.json file and add the Drizzle Studio command to your scripts. Run the Drizzle Studio command and open up Drizzle Studio. Drizzle Studio allows you to view your tables and also provides a query runner so you can execute SQL queries and explore your data. Now that we have Drizzle Studio running, we're going to go through the typical codebase first schema workflow. This is the typical pattern I see developers using when working with Drizzle. You start by creating a directory that contains all your Drizzle schemas. You define your first SQL table with Drizzle's SQL table method, and then you specify each column and the column's corresponding data type. Valid data types vary depending on the type of database, so it's best to look through the Drizzle docs to see all the valid types for the database you are running. After specifying a schema, you can then import it into your codebase. You can create a Drizzle database object with a Drizzle method that is specific to your database type. The D1 database is available in the context of the serverless request, so all you'll have to do is place the D1 database instance into the Drizzle method. Just make sure that you bind your D1 database in your application in the Wrangler TOML file, and then you generate the binding types. If you're not familiar with this process, I have an entire video that walks through it in detail. If you're using Postgres or MySQL, you typically define a connection first that gets placed inside your Drizzle method. From here, you can start crafting type-safe queries behind an API or server-side component. The Drizzle docs have detailed examples on all the database access patterns, so you can delve into the docs to learn how to craft more complex queries. For this example, I'll just be showing a basic query on how to select data with a filter and how to insert new records behind an API. We'll go ahead and start this app up. It's probably obvious to you that we'll throw an error when calling the create user endpoint because we have yet to create the user table. We'll continue with the codebase first approach and run the Drizzle generate command. This command is going to look at all our Drizzle schemas and will output actual SQL statements to create or modify tables. To do this, we'll need to tell Drizzle where our schemas live. We'll also need to specify where we want the generated SQL statements to be placed. We'll add the generate command to our scripts and then run npm run drizzle generate. You can see that this command creates a new folder, and inside that folder there's a SQL file with an actual create statement. Now you could copy the SQL statement and head over to the Drizzle Studio. Running this query there would create the table for us. But following the codebase first approach, we can manage table schema changes with the migrate command. We'll add the migrate command to our scripts and then run npm run drizzle migrate. When this command finishes running, we can see that a new table has been created, and we can also successfully call our create user endpoint. After adding a new user, you'll be able to see data in the users table. Now let's say you want to create a column that contains the time the user was created. We can head back to our schema and add the created column. Also make this column default to the current time whenever a record is inserted. We'll run drizzle generate. We can head over to the new SQL file that has been generated. Here you can see there is an alter table statement that sets a default time whenever a user record is inserted. Let's run migrate and add another user. You can see that we now generate a timestamp when we add a new user. This is a prime example of the codebase first approach where the source of truth for your table schemas sits inside your codebase. This pattern allows for rapid development as it abstracts much of the schema management away from you. But I also find the codebase first approach hard to scale beyond a single developer for a project, as it is easy for schemas to become out of sync. To illustrate this problem, I'll clone the project into a separate directory. I'll now add a new column and I'll migrate the change to our database. Now let's say you're working with somebody else on this project who is also working with the users table. This developer doesn't know you've already created a new column and goes through the process of creating the same column. After generating the SQL for the new column, they try to migrate, but they encounter an error because the column already exists. If you want to keep your schemas in sync with the codebase first approach, you'll have to commit your Drizzle output and schemas after each change, and then communicate with everybody working on the project that there are changes that need to be pulled. This can become a lot of overhead as your team grows. Now, if you're a backend engineer or a data engineer, you probably think that the codebase first approach sounds crazy. Professional development teams usually have a centralized tool to manage table schema changes. When creating or changing a schema, there is typically an approval process with a series of stages before changes go into effect. It is then up to the developers using the table to understand the shape of the data. In the Drizzle docs, this pattern is referred to as the database first approach. To illustrate this approach with Drizzle, I'm going to delete the Drizzle output folder, the schemas, and the tables that we have already created. We're basically going to start from scratch here. I am now going to modify the Drizzle config slightly by changing the path for both schema and output to a directory called models. I'll then add the Drizzle pull command to the project scripts. Now we can showcase the database first approach by creating a table with raw SQL. Once the table is created, we will run the pull command in our terminal. Notice that this command created a models folder in our project. Inside this folder there is a schema file with an auto-generated Drizzle schema that mirrors our table. If we modify this table or add a new table, all we have to do is run the Drizzle pull command and the project schemas will be updated. I personally prefer the database first approach when working with Drizzle. It allows me to be more cognizant of table schemas, and it also forces me to be deliberate when creating indexes. This approach also makes working with a larger team easier, as schema changes can be pulled into the project whenever they occur. Path also opens up the door for creating a more sophisticated schema management process, where a centralized tool or GitHub Actions can drive schema updates. Ultimately, this flexibility is why I enjoy Drizzle. If I want to do really quick work and just get something out the door, I can manage schemas directly in the codebase. While at the same time, I have full schema management control if I want to introduce patterns that scale with a growing team. If you're already familiar with Drizzle, you might have noticed that I skipped over the Drizzle push command when talking about the codebase first approach. Drizzle Kit push allows you to directly push schema changes without generating SQL migration files. The command is very powerful, and it's the fastest way to modify tables. However, I find this command to be a bit dangerous as you don't have as much oversight of the actual SQL statements that are being executed. Now that we have gone over the entire process of managing schemas with Drizzle, let's talk about local development. If you're using Cloudflare D1 as your database, you can simply add a migrations path to your wrangler.toml file that points to the directory that contains all the SQL migration files. After this, you can run the wrangler D1 migrations command, which will create all your tables locally. You can then run your project in local mode, and your data will persist locally. If you want to explore the data that persists locally in Drizzle Studio, you can do so by creating a local Drizzle config file. Go to the .wrangler folder and find the SQLite file within the D1 folder. You can copy the relative path and then add it to the URL in your local config. Make sure to install Better SQLite 3 as a dev dependency. Then add the Drizzle Studio local script in your package.json file that points to your local Drizzle config. Run Drizzle Studio local, and now you'll be able to explore the data that persists when running in local mode. Before concluding this video, I just want to mention that I use Cloudflare D1 for many projects, and I have been really impressed with the experience and reliability. That said, I have not used the D1 database for high volume services that execute more than 20 queries a second. I am currently running a few experiments to test Cloudflare D1 under heavy load, and plan on making a comprehensive video about my findings if people are interested. If you have used Cloudflare D1 in a service with heavy load, I'd love to hear your experience either in the comments below, or if you prefer, shoot me an email. I really hope this video has provided you with a better understanding of Drizzle, and will help you build even cooler things.